On October 1st, 2025, the European Space Agency makes an official declaration. Mars Express and the Trace Gas Orbiter are set to monitor 3-2 Atlas as it swings by Mars at its nearest point. This isn't speculation or a tip-off, it's straight from the source. NASA's Mars Reconnaissance Orbiter, along with the UAE's Hope probe and China's Tianwen-1, are all locked in on the identical objective. 5 probes in total, representing billions in tech investment, line up in an ideal cosmic setup to give humankind our sharpest glimpse of an intruder from outside the solar system. But then, an odd twist unfolds. Quiet falls, no photos, no announcements, no info releases, just a fuzzy collection of 20 frames from a rover popping up on social platforms, handled by astrophotographer Simeon Schmaus, then fine-tuned and posted on X by well-known cosmologist Stephen Burns. That lone blur turns into the sole visual scrap the public lays eyes on. At the same time, China, a nation that bombards the web with countless Mars shots and hails every milestone as a badge of dominance, stays utterly mum. Zero comments, zero visuals. For a power fixated on flaunting its feats to the globe, that hush speaks volumes. And things turn even weirder. WST spectroscopy uncovers an unforeseen detail: nickel absent iron, a chemical makeup that has experts labeling it far more aligned with man-made sources than anything born in nature, by orders of magnitude. This unfolds as a 3-part journey. The first segment tackles the buzzworthy find and the data blackout. The second delves into the research and geopolitical angles, while the third uncovers fresh space developments overshadowed by the 3-eye Atlas frenzy. Before diving in, if this tale hooks you, smash that like and sub button. Drop a line in the comments. Where are you tuning in from? What's your view on the quiet? Comet or something more? If you're keen to amplify it, pass this along on X, Reddit, or your go-to spots. Appreciate you joining me. Time to uncover what's being kept under wraps. Section 1. The post that ignited everything. Screens flicker to life at 3 a.m., jolting folks awake. A lone update hits X, once Twitter, from a profile dubbed 3-eye Atlas Anomaly. The message is straightforward, almost offhand. The quiet from China rings loud. In moments, the stats skyrocket. The web, that vast shared nerve center, senses a peculiar throb racing through its veins. To grasp the full weight here, let's rewind slightly. On October 3rd, 2025, 3-eye Atlas reached its tightest orbit around the rusty world, zipping by at roughly 29 million kilometers or 18 million miles. Sounds remote, yet in cosmic scale, it's prime viewing territory. Several agencies had flagged their plans to track this uncommon spectacle. The European Space Agency readied Mars Express and the Trace Gas Orbiter for the watch. NASA's array of Mars probes and landers were prepped. The United Arab Emirates' Hope craft tweaked its gear. China's Tianwen-1, years into snapping the Martian terrain, sat ideally placed to snag groundbreaking shots of an outsider from afar. The buzz was palpable. Picture it. Our mechanical scouts dotted around Mars' skies and ground, all swiveling lenses to one sky spot. From 33.5 million miles away on Earth, we'd get a stellar view of this interstellar guest. We'd cross-check, gauge, analyze. The insights promised to be groundbreaking. Yet the insights didn't materialize. Or at least, not as anticipated. Rather than sharp overhead snaps, updates, bulk data shares, or research drafts hitting servers, something entirely different emerged. A streak. A disputed, hazy, stretched-out streak pulled from unprocessed files of NASA's Perseverance rover, refined by amateur analysts, blasted across online forums, and dissected everywhere online that ponders potential watchers lurking in the shadows. That post, plain yet piercing, nailed the contradiction spot on. For a nation hooked on touting its tech edge, for a program that churns out thousands of pics routinely, for a global heavyweight using Mars ventures to flex might, the hush isn't merely odd, it's thunderous. Yet China isn't the only one holding back. NASA hasn't dropped any up-close shots from its orbital sentinels. The European Space Agency, which touted viewing schedules from October 1st to 7th, has shared zilch from that key period. The UAE's Hope effort, usually quick to broadcast from the pioneering Arab deep space venture, stays tight-lipped. All the big names, all the lenses, All the tools meant to observe seem to have agreed in unison that this rare sky spectacle demands no public fanfare. When space organizations spot something noteworthy, the usual routine kicks in. It's a predictable drill, bordering on routine. Fresh photos stream down from probes, typically arriving in mere hours or days. They pop up on open-access sites, occasionally riddled with processing glitches like sensor flaws, dead pixels, or traces from space radiation. Experts dive into initial reviews while the info is fresh off the press. Media teams craft announcements. Academics gear up for publications. The gears of open scientific inquiry churn on, methodical and step-by-step. Holdups occur, no doubt. Limited data links, gear malfunctions, processing queues, or storage caps can stretch waits from days into weeks. Yet a complete blackout spanning various groups, probes, and countries? That doesn't align with standard procedures. Online communities hate empty spaces, and the web despises info gaps even more. Right away, two viewpoints emerge. One side, methodical and reserved, chalks it up to everyday workflow snags, technical hurdles, or worries about data quality. These are the insiders and hobbyists who grasp the ins and outs of orbital operations, aware that not all findings lead to breakthroughs, and recalling times when anticipated releases lagged for months or never surfaced. The other side detects orchestration, cover-ups, events big enough to justify an unusual hush across organizations. These folks pose the tough queries. How come every probe eyeing 3 Atlas hits data snags at once? How do rival agencies, usually vying for glory, sync up and shared quiet? The big unspoken query looms large. If 3 Atlas were merely a standard comet, an icy wanderer from afar obeying familiar laws of motion and makeup, why opt for secrecy instead of fanfare? Why would Beijing, after years crafting its image as a cosmic powerhouse, skip the chance to drop the first reveal, snag top visuals, and showcase its prowess to a global audience? As that tweet puts it, the quiet is overwhelming. And what turns quiet into something scary isn't the secrets it conceals, but the implications for those enforcing it. Part 2. The tube hovering over Mars. At first, the photo seems ordinary, just a fuzzy shot from a groundbot's lens gazing at an extraterrestrial vista. Then a tweak to the brightness, and there it is. A slender form shining dimly, arcing through the thin Martian air like a bright flaw on vintage celluloid. The post from Truthplex asks, "Does this strike you as a comet?" Another commenter, equally intrigued, posts a trimmed and hue-boosted edit, the thing now shaded emerald, borders sharp, shape hinting at a tube-like form with even inner light. Replies flood in with theories, metallic, engineered, unreal. This snapshot shattered the barriers. It's the lone visual clue that slipped past the seeming info clampdown, racing through networks quicker than any agency rebuttal. Sourced from NASA's Perseverance vehicle, via the Mastcam-Z setup, a dual-lens rig meant for snapping terrain and samples, not swift sky dwellers. The unprocessed files, per usual, landed on NASA's open repositories. What followed was grassroots sleuthing at its boldest. A data whiz from Germany, Simeon Schmuse, grabbed several shots, synced them to offset the bot's minor shifts, layered them to cut static, and boosted contrast to tease subtle traces from the haze. The outcome? That stretched shimmer now fueling all talk of 3 Atlas. Avi Loeb, astrophysicist heading Harvard's Galileo Initiative and a leading advocate for probing possible cosmic relics, cited this merged image in a Medium article, calling it a blur yet confirming its presence in the records. So what's really there? The everyday take is simple, almost underwhelming. When lenses snag a shifting light over sequential shots, particularly after syncing and merging, the shift alone produces stretching. Picture snapping a far-off jet after dark with extended shutter time. Its beams trail into a lit bar, faking a beam instead of a dot. The Mastcam-Z wasn't built for chasing quick astral movers. Its timing, speed, and correction tools, all tuned for still landscapes, team up to blur any transit across the lens. Layer on the digital post-processing tweaks were added retrospectively. Layering in effects generates unwanted distortions. Boosting contrast heightens background clutter. Faulty sensor spots, those rogue pixels that glitch and spit out bogus intensity readings, can produce phantom patterns that mimic real formations once they're stretched and smoothed. The greenish hue showing up in certain editions is likely just an artificial overlay meant to highlight subtle details, rather than the object's true hue. Folks familiar with handling astrophotos understand that the final processed view often strays far from the raw data captured by the gear. Still, this particular shot endures. The cylindrical reading lingers on account of this blurry, disputed, potentially glitch-filled blotch being the sole pictorial clue available to everyday viewers from the Mars viewing slot. It's not that superior shots are absent, it's that they've stayed under wraps. Satellites in orbit, equipped with sharper lenses, accurate alignment tech, and tools to follow dynamic targets, ought to have snagged conclusive proof. The Mars Reconnaissance Orbiter boasts HiRISE, a lens setup that can pick out Martian terrain details smaller than a meter. Mars Express and the Trace Gas Orbiter feature gear tailored for air layer studies and ground charting. Any one of these missions, if directed right, could have supplied snapshots to resolve the debate in a flash. Yet here we are with a mere blotch. And the human brain, that relentless scanner shaped by eons of survival instincts to detect threats in underbrush or profiles in mist, gazes at the blotch and discerns form, detects balance, senses purpose. Contrast that with the Hubble snapshot from July. That one, shared via official routes with data tweaks and expert backdrop, displays a textbook comet vibe. A glowing core enveloped in a hazy envelope. The vapor and grit cloud released as frozen bits turn to gas under solar heat. Its contour resembles a droplet, a bit lopsided, precisely the sort you'd anticipate from a grimy ice chunk heated by the sun. It appears organic. It feels benign. The Perseverance blotch resembles nothing of the sort. Whether that contrast mirrors true conditions or simply stems from pushing equipment past its intended limits is still up for debate. But the mental toll is clear. Conventional news sources latched onto the tale. Astronomy reporters penned guide articles, mostly measured, often doubtful, yet all nodding to the odd stir in the data flow circling 3I/Atlas. Fringe science sites, unbound by bureaucratic restraint, dove into bolder claims. The Debrief, an outlet zeroed in on mysterious events and space tech, dissected the photo and the ensuing quiet at length. The contagion had broken free. The tube in Mars' atmosphere turned into a viral hit, a quick symbol, a societal marker. Folks who couldn't distinguish a space rock from a comet suddenly weighed in on 3I/Atlas. The photo spread across sites that rarely touch stars. Content creators with niches in unrelated fields abruptly chimed in on cosmic intruders and cover-ups. And amid it all, the space outfits uttered not a word. No fixes, no details, no counter-narratives. Pure quiet as the blotch spoke volumes for them. What unfolds when the public gets only the crudest proof, doctored by hobbyists, routed via social feeds, detached from expert trust? You end up with precisely this mess. A tale that spins on its own. A storyline that plugs the gap from official hush. A shared hallucination fueled by digital specs and suspicion. The tube might prove a mirage. A play of rays and code. A warning on the perils of reading too much into fuzzy inputs. But the hush around it is utterly genuine. And that hush, beyond any snapshot, is what leaves folks tossing at night, thumbing through tweaked close-ups, repeating the query endlessly. Does this strike you as a comet? Part 3. For eyes, one blotch. 5 probes circled Mars on October 3, 2025, each loaded with tools costing hundreds of millions. Each primed to eye an extrasolar guest from an unprecedented human vantage. NASA's Mars Reconnaissance Orbiter, sent up in 2006, loops the rusty world every 2 hours, hauling the HiRISE imaging rig that spots dinner table-sized items from above. The European Space Agency runs 2 craft, Mars Express, orbiting since 2003, fitted with a sharp stereo imager and analyzers, and the Trace Gas Orbiter, which docked in 2016 bearing sensors to probe air makeup and snap fine-grained views of the terrain. The United Arab Emirates Hope, the inaugural Arab probe to venture beyond our planet, arrived at Mars back in 2021, equipped with specialized cameras and spectrometers tailored to examine the red planet's atmosphere and climatic behaviors. Meanwhile, China's Tianwen-1, which settled into orbit that same year and soon after dispatched a rover to the surface, features a suite of both satellite and surface-based tools for capturing visuals and conducting spectral analysis. Imagine 5 orbiting assets, countless imaging devices, and legions of researchers and technicians tracking signals, scheduling scans, and retrieving information. The viewing period for 3I/Atlas had been openly declared in advance. Officials from the European Space Agency made it clear that their Mars Express and Trace gas orbiter would monitor the comet from October 1st through October 7th. This wasn't some covert endeavor. It was pure, collaborative science, exemplifying the pinnacle of human collaboration when we transcend rivalries and direct our tech toward a shared celestial target. The nearest pass happened on October 3rd. 3I/Atlas zipped by Mars at roughly 29 million kilometers away, a distance close enough for even basic gear to snag sharp views of its coma formation. They could have gauged its spin speed, if it had one, or dissected the wavelengths of light bouncing off and radiating from it. Data retrieval from Mars probes follows a tried-and-true routine. Most satellites enjoy several daily links back to Earth. Urgent scans frequently snag top spots in the transmission lineup. Unprocessed photos usually hit public archives in mere hours or days, well ahead of any in-depth review. After all, openness isn't merely smart outreach. It's baked into the operational guidelines, tied to the public funds that support these ventures. So, where's the footage? As of this discussion, not a single verified close-up shot from any Mars satellite has surfaced officially. The available evidence boils down to amateur-edited frames from the Perseverance rover. You know, those debated composites that ignited the whole cylinder controversy. The orbital sentinels, the ones primed to supply irrefutable proof, are staying mum. To stay balanced and exhaustive, let's explore the straightforward reasons first, since leaping to plots without vetting options smacks of sloppy thinking. Managing spacecraft is intricate business. Aiming optics at a swiftly passing target demands exact orientation and synchronization. 3I/Atlas wasn't hovering still. It was hurtling across the sensor's sight line at kilometers per second against Mars. Maybe the alignment software glitched. Maybe they tried the shots, but the thing looked too dim or blurred to yield value. Maybe glare from Mars itself washed out the frames, making them useless for research. Maybe the files got mangled en route, zapped by radiation or hardware hiccups. Such mishaps occur. The cosmos is unforgiving. Gear breaks down, info vanishes, and the line between triumph and flop can be perilously slim. Even top-tier operations hit snags now and then. It's conceivable that every probe, hit by a perfect storm of misfortune and glitches, just couldn't grab anything worthwhile. Improbable, sure, but feasible. Don't overlook the processing and verification logjam either. Fresh captures often demand heavy editing before they're ready for sharing. Faulty pixels must be hidden, shape tweaks fixed, brightness balanced out. That demands effort and experts. Maybe the pics are there, buried in a backlog, pending a swamped specialist sign-off prior to going live. Maybe bureaucratic or organizational checks are dragging feet, not due to some bombshell content, but because red tape crawls, and juggling agencies creates layers of sign-offs. These scenarios hold water. They're the dull, aggravating truths that define so much of cosmic probing. No intrigue, no schemes, just the tedious drag of massive entities syncing up amid borders, schedules, and clashing agendas. Still, the contradiction lingers. Vast fortunes in tech, ages of preparation, bold declarations of intent to watch. And yet the sole visual swaying views is a fuzzy blot from a ground crawler not built for such duties. The gap in knowledge is immense, tucked away on drives and systems spread from the U.S. to Europe, the UAE, and China. The genuine shots undoubtedly reside. They were snapped, beamed down, archived. Experts have eyed them. Controllers have pored over them. But the everyday folks, the funders via taxes, the society whose wonder drove these craft through the void, gets zilch. That global blur turned into ridicule, a viral gag, an emblem of systemic breakdown or hidden agendas, depending. It all hinges on how you view it. Metrics from social platforms paint a vivid picture. The enhanced photos from Perseverance sparked millions of views, thousands of reposts, and endless discussions in comment sections about their true content. Typically chatty official profiles from the space agency, which flood feeds with Mars visuals, fell strikingly silent over that key viewing period. No hints, no status reports, no promises of upcoming reveals, just a strange void in the usual stream of updates. Does this fit the norm? Could a joint effort by multiple organizations just slip away into processing queues for weeks or even months without any nod to the public? Responses vary by source. Seasoned participants from earlier expeditions explain that holdups are commonplace, that waiting is essential, and that solid research demands time. Yet they concede that this unified hush among groups, usually vying for attention, stands out as odd. The appearance is dismal. The emptiness breeds rumors. And once those rumors embed in the rich ground of online spaces, they spread quicker than any rebuttal can contain them. We're stuck with an awkward reality. The priciest monitoring array ever deployed near a distant world tracked an object from beyond our solar system. And the official documentation boils down to a single disputed photo tweaked by an amateur analyst using rover feeds, while the entities that vowed to monitor stay mum. Whether that quiet stems from everyday red tape or a calculated choice remains unclear for now. But the inquiry persists, unresolved and growing more pressing. What exactly did those 4 observatories capture? And why do we have just one blurry shot rather than scores of sharp ones? Part 4. China's resounding hush. For a nation fixated on flaunting dominance, the quiet from China stands as perhaps the most telling sign. The China National Space Administration shuns understatement. Ever since Tianwen-1 settled into Mars orbit back in February 2021, the project has served as a triumph of promotion, a meticulously staged showcase of technical might aimed at declaring China's emergence as a space-traveling giant. Data drops adhere to a steady pattern. Collections of shots highlighting the orbiter's strengths, ground-level snaps from the Zhurong rover probing Utopia Planitia, media briefings scheduled for peak exposure at home and abroad. Since launch, thousands of pictures have gone public, sweeping vistas of reddish sands, detailed views of stones possibly shaped by long-ago floods, overhead charts of magnetic formations. Each drop comes with declarations spotlighting Chinese ingenuity, Chinese craftsmanship, Chinese research dominance. This isn't a jab, it's a note. All space outfits play the PR game. NASA stamps its mark on every shot. The European Space Agency crafts polished clips hailing Rosetta's comet touchdown or the endurance of Mars Express. The contest for space supremacy never stopped. It just shifted from arms to acclaim. In that contest, China has charged ahead, keen to equal and outdo the veterans, resolved to demonstrate that a controlled, tech-driven system can rival and eclipse open society exploration. So when Oumuamua swung nearest to Mars, when Tianwen-1 enjoyed prime positioning for an occurrence set to headline global science news, when leaders in Beijing could have unveiled the premier and finest views of an extrasolar guest from off-world vantage, what action did the China National Space Administration take? Zero, at least in the open. No statements proclaiming triumphant captures. No sample visuals shared with government outlets. No research drafts posted to domestic archives. No updates on verified channels trumpeting this landmark occasion. The standard hype engine, so dependable and boisterous, ground to a complete stop. Up to the time of this account, no output from the China National Space Administration has surfaced publicly featuring specific Oumuamua visuals from the Mars viewing slot. To stay utterly objective, the China National Space Administration frequently groups its outputs, occasionally withholding info for weeks or months to roll out thorough collections later. The lack of prompt visuals doesn't automatically spell concealment. It could just mirror standard procedures. Maybe the info is under meticulous review. Maybe experts are gearing up for a big study. Maybe the rollout aligns with local policy shifts or global gatherings. These make sense as straightforward reasons, yet the backdrop is compelling. The European Space Agency openly detailed its plans for Mars Express and the Trace Gas Orbiter. NASA's Mars efforts disclose aiming windows clearly. Both outfits generally share initial findings soon enough, even as deeper reviews drag on. The parallel quiet the notable aspect that every key stakeholder seems to have agreed upon is their refusal to distribute photos from this particular occasion, which troubles analysts and sparks rumors. From a global politics standpoint, This quietness represents a squandered chance that's nearly baffling. China's efforts in space aren't solely about conducting research. They're also about proving that the nation can perform research as effectively as, or superior to, any other country. Ventures to Mars cost a fortune, carry high political stakes, and demand cutting-edge expertise. The payoff extends beyond mere discoveries in science. It's about elevating a country's status on the world stage. When India's Mars orbiter succeeded right out of the gate in 2014, outpacing China to reach the Crimson World, the disappointment echoed loudly through Chinese news outlets. A power that had already sent humans into orbit and touched down on the moon's hidden side found itself outdone on Mars by a less powerful ally operating on a shoestring budget. Tianwen-1 emerged as the direct response to that setback. This all-encompassing endeavor featured an orbiter, a lander, and a rover, all pulling off the task flawlessly on their debut try, a milestone unmatched by any other country. The intent shone through plainly. China had closed the gap, and now it was surging forward. Each follow-up data drop hammered home that point. Behold our capabilities. Witness our reach. Marvel at the sophistication of our tech. So, given a prime moment to seize the most stunning visuals ever from their Martian pursuits, why would Beijing opt for reticence? Why let NASA and the European Space Agency dictate the storyline by omission, even if it's mostly amateur-edited rover shots instead of sanctioned outputs? Why forego the shot to outshine the U.S. by dropping exclusives first, asserting research dominance, and soaking up worldwide spotlight? Viewing it through cultural and media lenses reveals more depth. In China, the spread of information faces strict oversight. Weibo, the leading social network, undergoes intense monitoring. Content on delicate subjects vanishes swiftly. Popular tags get quashed. Should a formal or quasi-official drop of 3 Atlas shots emerge and then fade from Chinese sites, it would align with long-standing tactics for managing data. We've witnessed this pattern in cases ranging from environmental crises to governance controversies to humiliating tech glitches. In a tightly regulated infosphere, a lack of proof doesn't confirm nothing happened. Yet it hints that if noteworthy items surfaced and then got scrubbed, we might stay in the dark forever. The theorizing, and it deserves to be called just that, lacking solid proof, is that elements in the Tianwen findings caused Beijing to pause. Maybe the pics proved unclear, inflammatory, or prone to sparking the wild public chatter that strict regimes loathe. Maybe a plea came in, official or not, from fellow space outfits or security/military groups, urging restraint until deeper review. Maybe the choice to stay mum stemmed from joint planning, tied to a broader pact among organizations that spans national lines, since certain revelations carry weight too heavy for solo announcements. Or maybe, and this dull take could well be spot on, the results plain underwhelmed. Perhaps the alignment faltered. The shots came out fuzzy. The clarity against interference fell short. And Beijing opted wisely against sharing mediocre stuff that could draw ridicule over respect. In the equation of image building, skipping a slot beats airing a flop. We lack the means to find out, nor can we, absent the raw files or candid words from the China National Space Administration on their hush. What stands out is the hush in itself, its presence, its match with quiet from other bodies, and its stark shift from typical conduct. When a regime accustomed to proclaiming loud opts for subtlety, when a space initiative hungry for eyes abruptly shuns them, the void of noise turns into its own echo, and that echo, as the initial post noted, rings out intensely. Part 5. Away from public view, China's reticence signals goings-on hidden from sight. The phrase pops up on a display from an account named Orwellano90, nailing the atmosphere just right. Two rival ideas clash over the online gap. Both make sense, both draw on bits of support, both push us to pick a lane. One idea feels everyday and aggravating. Hold-ups in data handling, messy readings, zilch worth hurrying to share for science's sake. Bureaus behaving as they do, progressing deliberately, verifying meticulously, dodging hasty declarations. The other idea feels wild and alarming. The findings reveal oddities, formations, actions that clash with what's expected in nature. Ordinary items, along with a short-term hold on disclosures, as authorities and research bodies determine the right words to use without sparking widespread alarm. We should scrutinize each possibility with the gravity it warrants. The ordinary account draws from years of expertise in space endeavors. Running spacecraft involves intricate procedures. Gathering data marks just the initial phase in an extended sequence that encompasses sending, verifying, adjusting, evaluating, expert scrutiny, and dissemination. Even urgent findings might require weeks or months to navigate this chain. Researchers proceed with care due to their education and the demands of their field. Releasing flawed outcomes can harm reputations and organizations. It's preferable to invest additional effort in thorough verification and agreement building rather than hurrying publications that could later cause regret. Moreover, not all sightings yield results. Equipment malfunctions, alignment mistakes happen. Ambient interference can overwhelm subtle indications. Maybe the object dubbed 3 Atlas proved uncooperative for observation. It could have appeared fainter than anticipated, its surrounding haze more spread out, or Martian solar glare hindered clear photographs. Multiple entities might have separately decided their records offered no fresh insights beyond Hubble's July shots. Such unglamorous yet credible situations explain the delay. In opposition, the unusual theory demands faith in synchronized restrictions on info across competing nations and space entities, choices made beyond scientific circles. It calls for envisioning military and spy agencies getting involved, security risks evaluated, discussions in protected spaces where experts inform leaders about sightings defying standard explanations. What mechanism would enforce such a hold? Space programs function as civilian entities, at least on paper, yet they fall under state oversight and rely on public funds. Should a secretive agency or its foreign counterparts urge a halt to data sharing for review, backed by solid rationale and clout, agreement could be presented as willing partnership instead of suppression. Experts wouldn't face silencing. They'd just be urged to pause, allowing specialists to review and prevent needless fright from findings with benign roots. Past examples abound, if imperfect matches. The Rosetta probe to Comet 67P/Churyumov. Gerasimenko faced surprising traits needing time to unpack. Certain releases lagged as teams debated meanings. U.S. government closures have halted NASA updates, leading to brief gaps in public access unrelated to the material's nature. The veil of confidentiality over select space tech, especially with defense potential, stands well recorded. Orbital phototech, drive mechanisms, signal methods. These often stay restricted or dribble out under tight rules. Yet, 3I Atlas isn't a defense orbiter. It's a visitor from beyond our system, a cosmic body that excites researchers. Why would states meddle to this degree? If the extraordinary idea holds, the response hinges on consequences. Should the readings reveal traits clashing with natural origins, odd makeup, or forms hinting at intent, the issue shifts from academic interest to a crisis of worldwide import. How does one inform 7 billion that solitude in the cosmos might end, that an unknown entity approaches, its motives and source a mystery? How to avert chaos, sustain stability, align global actions? You gain breathing room. You enforce brief quiet. You gather specialists in private. You game out possibilities. You shape announcements. You settle on phrasing and timing. Meanwhile, the unaware populace detects unease. The void of updates signals trouble, a hush pregnant with fear. The Martian viewpoint proves crucial here. Earth-based views of 3I Atlas offer a single angle. But Mars Vantage yields cross-checks, spatial insight, chances to gauge shifts and map full shapes. If the item revealed patterns unlike a spinning frozen chunk, displayed mirrored forms or etched like marks, or displayed shifts in light implying guidance, Mars Sightline would seal it, the proof turning guesswork to fact. And that leads to the puzzle hiding under each level of TH. It's all shrouded in enigma. What insights would such information truly reveal? How might an artificial visitor from beyond our stars appear? Would it scream technology, covered in antennae and solar arrays like a prop from a sci-fi blockbuster? Or could it blend in seamlessly, engineered for deep space journeys beyond our comprehension, its intent and source puzzling even experts? Would we spot it immediately for the marvel it is? Or would debates erupt, dividing us into factions, clashing over meanings as the thing hurtles along its eccentric trajectory out of the solar system and into the void. The chemical findings, which we'll delve into soon, only intensify the intrigue. Early spectral scans pointed to odd makeup, notably higher levels of carbon dioxide compared to water vapor, plus traces of nickel unpaired with iron, features rare among familiar comets. Should the Mars readings validate or amplify these oddities, layering structural peculiarities onto the molecular quirks, it gets tougher to brush off notions of the remarkable by blaming glitches or analysis flaws. We're stuck in suspense, teetering between the ordinary and the phenomenal, stalled until the overdue info surfaces. In private huddles, if the wild theory holds water, those privy to the details are locked in discussions we can merely speculate about. Researchers unveiling findings, authorities probing further, hazard evaluators simulating outcomes, PR teams crafting responses. Beyond those sealed rooms, the public lingers, scrutinizing the quiet, gauging its depth, its gravity, its portents. The hush won't endure indefinitely. Facts, like leaks in a dam, seep out eventually. A voice will emerge. A detail will escape. You can't seal off the info flow forever. Not in this era of online networks, amateur reporters, digital intruders, and insiders gone rogue. Sooner or later, we'll uncover what the probes captured as they aimed at 3I/Atlas during its Mars close approach. The real puzzle is the delivery. Via polished official releases, neatly explained and situated, or via drips of unofficial intel, whispers, and piecemeal reveals that stir up more chaos than insight? For now, all we hold is the quiet, the blur, and the mounting conviction that events are unfolding in realms we can't access. Part 6. The info that vanished. NASA's planetary data system serves as the central vault, an immense online trove meant to house probe readings eternally, open to all with web access and the grit to sift its tangled corridors. The European Space Agency runs a counterpart, the Planetary Science Archive, a mirror realm of visuals, analyses, and signals from ESA ventures to Mars, Venus, icy wanderers, and satellites across the cosmos. These stores aren't mere perks or discretionary perks agencies bother with at leisure. They're baked into the mandates, stipulated by grants, demanded by guidelines, the cost of taxpayer-funded exploration. Openness is the bargain. We fund your cosmic machines with fortunes, and you deliver the raw goods, complete, refined, annotated, and gratis. So amid these colossal info silos, where hide the 3I/Atlas sightings from the Mars encounter period? Let's trace the hunt step by step, precisely, to grasp what's present and what's glaringly missing. Begin at the planetary data system, zeroing in on Mars probe zones. Head to Mars Reconnaissance Orbiter's high-res photo drops. Narrow by time frame. October 1st to 7th, 2025. Input keywords. 3I/Atlas Interstellar Intruder Guest. The output is barren, tauntingly so. Zero specialized photo collections. No tracking records labeled for the visitor. No announcements tied to uploads. Shift to Mars Express via the ESA Planetary Science Archive. The layout varies. The setup adheres to EU norms, yet the core logic persists. Probe the catalog for scans and the key dates. Seek spectral profiles, visual captures, alignment records signaling a pivot toward 3I/Atlas's projected spot. Once more zilch. Or at least, nothing clearly marked or easy to grab. Maybe the files lurk unlabeled, tucked beneath bland routine codes, awaiting a sleuth with sharp terms and dogged effort to unearth them. Yet if so, it signals a data handling breakdown so severe it borders on intentional. The ESA's pre-flyby public word was clear. Mars Express and the Trace Gas Orbiter would target 3I/Atlas from October 1st to 7th. That wasn't some fuzzy aspiration or tentative scheme. That was a NASA unveiled its observation effort. Typically, such dedications lead to press statements, online articles, photo collections, and dataset releases. The lack of any subsequent updates feels strikingly odd. Organizations reveal these initiatives to generate excitement among the public, to support funding requests, and to highlight the importance of their objectives. Yet when those initiatives disappear without clarification or outcomes, doubts start to pile up. Enthusiasts in the online community on X, once called Twitter, have been meticulously aligning timestamps, reviewing viewing timetables, and analyzing upload trends from before and after the close approach. Their assembled insights, gathered into extensive discussions and collaborative files, reveal a clear void in the records. Standard mission activities pressed on. Photos of Mars terrain continued to surface. Everyday research proceeded as usual. However, the Atlas III view seems wiped clean, as though archives were deliberately cleared of all traces connected to this cosmic newcomer. Now, prior to diving into wild theories, let's revisit the straightforward rationales once more, since fairness in reasoning requires it. Maybe the alignment wasn't quite as accurate as anticipated. Orbiters around Mars are mainly built for scrutinizing the red planet, not for following swift travelers across the starry backdrop. Steering mechanisms fine-tuned for direct downward gazes at the world could falter when aiming at sideways objectives that demand quick adjustments and exact following. Maybe the viewing efforts encountered technical glitches, and officials chose against announcing unsuccessful tries since there wasn't much noteworthy to share. Maybe the contrast between signal and interference was just too poor. The III Atlas, visible enough for Hubble to photograph from low Earth orbit, could have appeared far fainter from Mars vantage, particularly if its hazy envelope wasn't angled helpfully toward the instruments. Maybe light scattered from Mars proper, solar rays reflecting off the air layers, and ground-generated clutter that overwhelmed the subtle glow from the icy body. These represent the everyday hurdles that torment stargazing science. The gap between concepts and actual outcomes, between desired shots and what natural laws permit. Maybe alignment checks turned out trickier than foreseen. Unprocessed shots from probes frequently include flaws, like glowing spots, capture errors, data squeezing effects, shape warps from optical elements, or detector traits. Eliminating these calls for meticulous handling, matching views to test standards, and deploying fixed routines that might span days or even weeks. Maybe the groups handling this are short-handed, overburdened, facing piles from other urgent viewings. Maybe the Atlas III info is just queued up in some system, biding its time. No plot needed, just the typical drag of big outfits with scarce means. Another angle involves regulatory or governmental checks, not due to any remarkable findings, but merely because various countries and groups participated. Harmonizing releases among global allies can turn into a bureaucratic headache. Who releases first? Who claims the spotlight? What wording goes into the announcement? Such trivial concerns, though they appear minor, can hold up info drops for weeks as attorneys and managers haggle. Research thrives on teamwork, yet researchers and their setups still vie for acclaim, grants, and first dibs. The more intriguing ideas, marked firmly as guesses, touch on purposeful data management. Maybe a cross-agency directive came down to withhold photos for a bit. Maybe it originated from spy outfits fretting over security matters, anxious that close-up shots of pursuing a speedy target could expose orbital assets or detection gear kept secret for defense purposes. Maybe it stemmed from foreign affairs routes, an effort to align statements on a find that everyone deemed weighty enough for cautious treatment. Maybe, and this ventures into the grimmest guesswork, military radars caught something the public tools overlooked or verified, leading to a high-level call beyond the space offices to halt sharing until experts weighed the meanings. The US, Russia, China, and fellow space nations run vast orbital monitoring setups aimed at following crafts, junk, and risks. These systems outstrip public scopes in sensitivity and power, even if their details stay under wraps. If those detectors spotted odd actions from III Atlas, like path shifts or glow variations, or build features hinting at more than a standard space rock, public offices might get told to sit on data as specialists assess the fallout. These ideas lack evidence. They're hardly probable, but they remain feasible. And without official accounts for the missing data gaps essentially plug the holes left by official reticence. Our brains crave stories. In the absence of solid evidence, rumors and theories proliferate. The more time passes without agencies offering clear answers, the wilder and more distrustful those counter-narratives grow. It's important to remember that both NASA and the Hubble team did release details on III Atlas earlier this year. Projections of its dimensions, orbital paths computed from observations, and material insights derived from spectral analysis. All these surfaced in formal reports and academic journals. The organizations haven't stayed entirely quiet on the subject. What's notably absent, however, involves photos and readings from the Mars close approach phase. That brief interval during which various probes, positioned for optimal views, ought to have gathered their prime records. This targeted hush is precisely what sparks such intrigue. Databases can be scoured, records reviewed, trends examined. Yet if the information was never posted, or if it went up using vague labels that avoid any mention of 3-2 Atlas, even the most thorough amateur researcher ends up with nothing. The setup of these repositories relies on trust, on the expectation that project crews intend for their findings to be discoverable and shared. Should that trust erode, should info get concealed right under our noses via poor tagging or simple exclusion, then public access rights turn hollow, more ideal than real. This leaves us facing a stark imbalance. The systems for openness are in place. The guidelines insist on it. Past practices back it up. Yet the records from the year's most hyped monitoring effort, featuring billions in equipment costs and bold declarations of purpose, are nowhere to be found where they belong. Whether this void stems from glitches, administrative chaos, or intentional withholding remains unclear for now. Still, the void qualifies as a concrete issue, one we can confirm, and that unsettles us, anchoring all the oddities in the Throwaway tale. The info that failed to materialize has turned into the very topic dominating discussions, its sheer absence granting it greater influence than any photo ever could. Part 7. When blur evolves into form. Let's circle back to the persistent visual that refuses to fade. That stretched-out radiance serving as the iconic emblem for the whole enigma. Retrieve those refined perseverance shots once more, the composite frames depicting 3-2 Atlas as a luminous trail set against Mars' backdrop. Magnify the enhanced contrast editions, the close-ups revealing the entity as tube-shaped, with steady luminosity running its span and what certain viewers call defined borders plus inner features. Examine the artificially colored renditions, those shaded in green or boosted to highlight faint nuances. Does this strike as organic? Does it resemble a rotating comet core enveloped in a hazy envelope of vapor and particles? Or does it suggest an alternative, something structured, something alien to our familiar classifications? The human gaze represents an evolutionary wonder and a generator of illusions. We detect visages in vapors, beasts in stone shapes, designs in chaos. Pareidolia, that inclination to discern significant forms in vague inputs, is embedded in our brain's wiring. It safeguarded our forebears, aiding detection of disguised threats and concealed provisions, but it also renders us prone to errors in decoding cluttered inputs. A haze morphs into a tube, an optical illusion turns into substantiation. A glitch transforms into an artifact of true craftsmanship, signaling purpose and craftsmanship. Thus, we must proceed with due caution, balancing healthy doubt with the curiosity essential to scientific inquiry. Begin with the idea of motion smearing. The simplest rationale. As a sensor records a shifting light point, particularly over sequential exposures that get synchronized and layered, the shift produces stretching. The stretch's orientation ought to align with the path of movement. Its extent should align with the angular speed times the shutter duration times the frame count. This follows fundamental motion principles, something foreseeable and verifiable. If the tubular form arises entirely from such mechanics, then no puzzle exists, just flawed reading. However, certain experts argue the even light spread inside defies basic streaking. For a light point dragging over a sensor, the path usually displays intensity shifts, stronger midway where rays cluster, weaker outward where captures thin. These composite shots, per those experts, exhibit near-even illumination across the entity's length, implying not a blurred, but a prolonged emitter with built-in form. They highlight what they see as precise margins, limits too defined for a comet's fuzzy sheath. Additionally, there's the debated assertion of a shiny metallic stripe or reflection apparent in select P. In examining these processed versions, there's a noticeable reflection or emission trait that appears blatantly unnatural. This marks the point where the debate intensifies, with doubters and proponents diverging entirely. One side identifies clear signs of image manipulation, like intensified hot pixels from boosted contrasts, or color adjustments fabricating patterns in empty spaces. The opposing view detects elements deserving deeper scrutiny. It's a potential indicator that demands the raw data and thorough verification before rejection. How might we verify it properly? At its heart, science relies on replication and forecasting. Should 3 atlas possess a stretched cylindrical form, then sightings from varied perspectives and moments ought to reveal uniform shapes. The perceived dimensions and breadth would shift foreseeably according to viewpoint, adhering to perspective geometry principles. Captures from diverse tools should align on core outlines once adjustments for resolution and spectral response are made. Moreover, if the stretching stems solely from motion blur in the Perseverance shots, we could compute the anticipated streak using the object's established path and the imaging system's properties. Should the detected extension surpass motion blur's limits, or if its alignment deviates from the expected movement vector, the structural idea strengthens. Such assessments involve basic orbital dynamics and sensor details, all accessible publicly. Yet the issue persists, lacking diverse, standalone records and lacking superior imagery from Mars satellites, which ought to have recorded far better details. We can't conduct these checks. We're left with unclear proof, just one batch of photos from a device not built for such tasks, handled by earnest hobbyists whose methods could generate as many distortions as discoveries. The cylinder might exist. The cylinder might be deceptive. From this evidence only, distinction proves impossible. Abby Loeb's blog entry lending weight to the layered blur lens some bolsters the finding, mainly since Loeb is an established astronomer linked to Harvard and the Smithsonian Astrophysical Observatory, not some fringe conspiracist or UFO aficionado. Loeb has stirred debate lately through his openness to probing interstellar relics and alien tech, yet he stays an active researcher with vetted journal articles and a career at stake. His focus on 3 Atlas doesn't confirm artificial origins, but it affirms the sighting merits review instead of outright scorn. The sharp contrast to Hubble's July shot proves revealing. That Earth orbit capture, months prior to the Mars approach, displays a textbook comet profile. The core measures small, maybe a few kilometers wide judging by luminosity and estimated reflectivity. The surrounding haze forms evenly, droplet-like, just as vaporizing ices would yield under sunlight's warmth, releasing vapors and particles. Any tail would trail sunward, driven by solar wind and radiative forces. The Hubble view epitomizes a comet, a frozen remnant of solar system birth, hurled from elsewhere and now traversing ours. Then what accounts for the Perseverance shot's oddity? Angle of sight could clarify it. The Mars vantage might expose features obscured or smeared in terrestrial observations. Rotation could present varying aspects across views. Or, venturing into the bizarre, the body might have transformed from July to October, shifting its look beyond typical comet behavior. That final option evokes speculative tales, but let's weigh its demands. Comets evolve, sure. Their outbursts rise and fall as new ice patches face the sun. Spouts burst from key sites, yielding uneven hazes and odd accelerations sans gravity. Spinning varies light output as facets turn visible. A July-seen comet could differ markedly by October via routine mechanisms, but evolving from balanced haze to evident barrel-like form pushes credible comet science to its edges. Additional information is essential. That call echoes repeatedly in research talks, embodying caution and impatience. Such records surely exist. Mars reconnaissance craft likely hold frames that could clarify everything at once. One calibrated, high-clarity image from HiRISE or Mars Express, shared openly, would end the morphology argument decisively. It might reveal a standard comet core amid its envelope, or perhaps something atypical, some rather than diving into something that would demand fresh breakdowns and awkward inquiries. We've ended up with a blurry mark that one side of the online world sees as a cylindrical shape, while the other brushes it off as mere static. The real story frustratingly stays sealed away in restricted records we can't reach, or maybe it was never recorded at all due to glitches we have no way to confirm. The shape, the structure, the true nature of 2I/Atlas as observed from Mars, hangs in a quantum-like haze of options, unproven and unrefuted, poised for a data drop or an insider reveal to resolve the uncertainty and reveal exactly what those detectors picked up. Part 8. The nickel oddity and the 10 to the power of 28 theory. Chemistry doesn't deceive, yet it can pose puzzles that keep stargazers tossing at night. The James Webb Space Telescope, our latest and most advanced infrared eye in the sky, aimed its gear at 2I/Atlas right before the Mars close approach. The near-infrared spectrograph, built to break down light into its spectral parts and uncover the molecular signatures of far-off bodies, gathered readings from the comet's coma, that hazy envelope of vapor and particles encircling the core. The results were odd enough to prompt submissions to AR-14, the go-to platform for astronomers to post findings ahead of formal scrutiny, and intriguing enough to fuel debates that straddle the boundary between solid research and wild guesses. The standout signal in the data is carbon dioxide, showing up in much greater quantities than water vapor. That's peculiar. The comets we've examined so far, those born within our solar system, usually consist mainly of water ice, with carbon dioxide playing a supporting role. The proportions are generally flipped. Water leads, carbon dioxide trails behind. But 2I/Atlas flips the script. Its coma, dominated by carbon dioxide, hints at either a radically distinct birthplace or a makeup that sets it apart from homegrown solar system wanderers. To keep it straightforward, picture a comet like a grimy ice ball, a blend of frozen gases, minerals, and carbon-based stuff from the dawn of planet building. The precise mix hinges on its origin point and era. Near a sun, water ice turns to gas readily, so such comets could lack water while boasting more easily vaporized stuff like carbon monoxide or dioxide. Out in the frigid fringes beyond a star's warmth, water ice holds firm, making comets water-heavy. The elevated carbon dioxide to water levels in 2I/Atlas point to origins in a hotter or atypical setting, or maybe water depletion from prior brushes with stellar heat during its galactic travels. It's odd, sure, but odd doesn't mean implausible. Comets vary widely. Each fresh discovery layers more nuance onto what we know. Take 2I/Borisov, the last interstellar visitor, which revealed unusually high carbon monoxide levels compared to our system's comets, a sign that alien star systems might brew different chemical soups. Thus, a carbon dioxide-heavy profile, though rare, doesn't scream anything beyond the galaxy's rich variety in chemistry. Enter the nickel sightings, and the tone pivots from curious to concerning. Various reports, from mainstream science sites to astronomer-run blogs poring over the spectra, have flagged nickel traces in 2I/Atlas's coma, but with scant or zero iron alongside it. This quirk grabs chemists and space scientists by the collar, as it defies what we anticipate from how atoms get cooked up in cosmic furnaces. Let's pause on stellar nucleosynthesis, the mechanism stars use to craft elements beyond hydrogen and helium. Modest stars merge hydrogen into helium. Bigger ones push further, blending helium into carbon and oxygen, then neon, magnesium, silicon, climbing the elemental ladder. The top-tier stuff, like iron and nickel, emerges from supernovae blasts, the cataclysmic endgames of massive stars that hurl enriched debris outward, seeding fresh stars, worlds, and icy drifters. Crucially, iron and nickel arise side by side in supernovae, locked in fixed proportions dictated by atomic rules. Spot one, and the other should tag along. The universe's standard iron-to-nickel balance clocks in at roughly 17:1 by weight. Comets, drawing from the same ancient stock as their host system's other bits, ought to mirror this, allowing for minor tweaks from mineral formation at varying heats. Nickel sans iron, or wildly lopsided nickel over iron, feels chemically alien. It implies a building process that somehow split these look-alike elements, or points to pollution, or hints at an object engineered to fake a comet's vibe from the outset. Certain watchers, tied to Harvard's Galileo project and the Initiative for Interstellar Investigations in Planetary Science, have highlighted this unusual nickel signature as possible indication of engineered chemical makeup that appears more manufactured than cosmic. The notion of a 10-28th odds ratio stems from Bayesian analysis of the probabilities involved. Consider the chances of a typical comet exhibiting this exact mix of traits. elevated carbon dioxide relative to water, nickel-absent iron, and perhaps a tubular form, and weigh that against the baseline odds of engineered items venturing through interstellar voids. Certain evaluations produce likelihood ratios that tilt heavily toward artificial origins, reaching ratios such as 10^28 to 1. These figures lack endorsement from peer-reviewed agreement. They stem from exploratory computations that rely strongly on chosen priors and uncertainty margins. Nonetheless, they reflect earnest efforts by qualified researchers to measure just how anomalous Oumuamua truly seems. To clarify, such Bayesian ratios are only reliable based on the starting assumptions you input. Beginning with a minuscule prior for extraterrestrial relics, like 1 in a billion, a strong data-driven ratio might still leave the final probability under 1%. On the flip side, adopting a more generous initial likelihood could shift the same evidence to suggest artificiality is probable. The math holds up, yet the foundational elements are interpretive, and flawed inputs yield flawed results. Moreover, the absence of iron alongside nickel remains under challenge. Certain spectral experts contend that iron's signatures exist but faintly, or that observational limits render iron tougher to detect than nickel in specific scenarios. Other theories invoke targeted vaporization, where nickel-rich materials evaporate before iron-bound ones stay embedded in durable particles. Issues of spectral overlap arise too, with clashing lines from various substances mimicking nickel signals, sans matching iron dips. This discussion is intricate, layered, and far from settled. Undeniably, though, Oumuamua's makeup stands out as atypical. Even doubters concede that point. The core issue boils down to whether atypical implies rare but organic, or signals an altogether different origin. Unlike visual data, chemical profiles resist easy distortion. Emission lines tie directly to atomic or molecular shifts. Fabricating a nickel line proves as impossible as inventing a unique identifier. Assuming the reading holds true, free of errors or mix-ups, the nickel exists, demanding an account for its isolation from anticipated iron. Counterarguments to the engineered idea warrant full attention and cannot be dismissed lightly. Cometary bodies vary in makeup across their cores, shaped by formation sites and mechanisms. Vapor release favors easy evaporating substances over stubborn solids. The surrounding haze we detect represents just a skewed snapshot of what's sublimating during viewing, not the full core profile. Sensitivity levels count heavily. Iron might lurk undetected below instrument resolution, while nickel appears more prominent due to fortuitous conditions, leading to an apparent solo act from insufficient scrutiny or methods. Contamination risks persist as well, not intentional deceit, but interference from nearby or distant emissions muddying readings. Orbital telescope spectra outshine Earthbound ones in purity, yet stray light, interplanetary particles, radiation bursts, and device quirks pose threats. Rigorous processing demands accounting for these, where slip-ups can spawn false positives or overlooked traits. The intrigue thrives on this ambiguity. Should the composition prove as bizarre as the boldest views propose, should Oumuamua defy standard genesis pathways, the repercussions would ripple far and wide like an expanding front. This isn't about traditional biology, tiny organisms on Enceladus or planetary air markers. It's about an interstellar traveler, potentially constructed instead of evolved, an entity that could upend our cosmic self-conception. Yet we're miles from that revelation. Evidence remains open to debate. Views clash without resolution. Scientific vetting hasn't forged unity. We're left with a compositional enigma shrouded in withheld details. A riddle resolvable via additional sightings, sharper readings, separate validations, elements expected from the Martian monitoring effort, yet maddeningly withheld from open access. Oumuamua's odd chemistry cries out for resolution, but the organizations holding the keys to clarity have opted, for undisclosed motives, to stay mum. Part 9. An unspoken pact between competitors. The National Aeronautics and Space Administration, NASA, and the European Space Agency vie for scientific acclaim, media spotlight, the acclaim tied to breakthroughs, and the grants that accompany such acclaim. China's aerospace initiative engages in fiercer rivalry, leveraging every launch to showcase technical prowess and strategic power. It's a message to the globe that U.S. Supremacy in orbit is waning, ushering in a world of multiple space powers. The United Arab Emirates, a relative newcomer to cosmic pursuits, strives for credibility, a place among the elite, and the esteem gained from advancing shared human understanding. These organizations don't partner solely from goodwill. They team up when common gains merge agendas, when pooling resources renders costly ventures viable, when global pacts and diplomatic protocols nudge them toward joint efforts. Yet under the surface of partnership, the race persists. Thus, when all prominent space entities with probes near Mars abruptly hush about the 3I Atlas sightings, when the usual scramble for first dibs on releases fades into unified quiet, experts spot the alignment. If it's alignment rather than chance, hinting at behind-the-scenes dialogues beyond single projects, deals struck in boardrooms and private chats beyond our reach, choices shaped by factors outside mere research. Let's outline the motivations plainly. NASA thrives on openness. U.S. citizens finance it, and public involvement bolsters funding requests. Sharing thrilling findings draws press attention, motivates future innovators in science and engineering, and sustains backing from lawmakers. The European Space Agency faces comparable demands, plus the challenge of aligning diverse nations with varying goals and contributions. Both have years of expertise in shaping public perceptions, in detailing successes and setbacks, in fostering confidence via candor. China's drives differ, yet remain potent. The China National Space Administration answers to a regime that prioritizes oversight, but also seeks global validation. Releasing standout achievements boosts status. Proving advanced skills bolsters defense by flaunting tech superiority to adversaries. In this light, the hush over 3I Atlas breaks from routine behaviors, calling for scrutiny. Perhaps the findings underwhelm, leading Beijing to withhold unremarkable outcomes, or they overwhelm. Too vital, too delicate, too loaded with ramifications needing deliberate management. The European Space Agency's forthright disclosure of viewing schedules undermines notions of a deliberate concealment. They declared plainly and publicly that the Mars Express and Trace Gas Orbiter would examine 3I Atlas from October 1st through 7th. This came prior to the encounter, shared on formal sites, echoed in news reports. Such candor opposes premeditated secrecy. One wouldn't publicize scans intended for suppression unless circumstances shifted, unless initial scans uncovered something major enough to prompt a later hold on releases, mutually endorsed. A hold differs from secrecy. Secrecy entails official restrictions, limited entry, and possible legal repercussions for leaks. A hold is gentler, an optional pact among stakeholders to delay announcements for deeper review or alignment. Academic outlets employ holds often, providing journalists advance peeks at studies with the stipulation of no release until a set time. This enables verification, discussions, background, ensuring even rollout across media instead of a rush for exclusives. Might a hold apply to 3I Atlas information? The process would likely be unofficial, sparked via discreet links among agency heads and state figures. Reasons could span mission safety, fears that precise orbit info might expose probe strengths, or diplomatic sinking, acknowledging that an odd find warrants joint revelation over solo claims. Or it could stem from research prudence, aiming to confirm oddities before sparking widespread conjecture. Past cases abound where knowledge and national aims clashed awkwardly. In the Cold War era, studies with defense uses were standardly sealed. Even now, select scans from orbital monitoring systems stay unreleased to guard detection tools and path tracing techniques. Delays in data amid tense global moments aren't rare. The handling of the Columbia shuttle tragedy demanded measured timing in disclosures. The deliberate timing of information releases is often used to prevent rushed judgments that could confuse families or the general populace. However, 3I Atlas isn't a defense initiative, nor a catastrophe, nor some secret operation. It's simply a comet, an astronomical body, a cosmic event that truly belongs to everyone on Earth. So why impose any restrictions? A plausible, though unconfirmed, explanation lies in the possibility that certain military monitoring systems spotted details overlooked by public observatories or too vague for clear identification. The orbital tracking setups run by the United States, Russia, and China outstrip civilian tech, by a wide margin. They detect items as small as baseballs in near-Earth space. They watch over satellites in stationary orbits for unusual activities. They'd certainly pick up on an object from beyond our solar system gliding past Mars. And they could capture features that ground-based or amateur scopes might miss entirely. Should those secure detectors pick up signs of artificial design, log unusual movements or light variations, or detect spectral signatures at odds with a typical comet, if security experts deemed 3i Atlas deserving of deeper scrutiny prior to going public, then public bodies might get a request to sit on their findings for a bit. Not indefinitely, not in some ongoing suppression scheme, but merely until specialists could evaluate the matter, authorities could align their approaches, and plans for messaging could be hashed out. This is pure conjecture, marked as such, yet it holds logical weight rather than descending into wild paranoia. Nations routinely collaborate on major occurrences. Take the gravitational wave breakthrough. It took several months of behind-the-scenes checks before the big reveal, motivated more by scientific caution than diplomatic concerns. Handling potential asteroid strikes gets managed via global forums exactly to sidestep one-sided declarations sparking alarm or international friction. Spotting hints of alien tech, even if tentative or unclear, would demand equal prudence. The twist here is that such joint efforts fuel doubts. Had every organization released their info on standard schedules, yielding nothing remarkable, folks would shrug it off. But this unified quiet, this timed lack of updates, fosters the illusion of a plot, regardless of whether one truly exists. The outfits involved have boxed themselves in. The extended holdup only heightens the air of secrecy. The more secretive it seems, the tougher it is to dismiss as everyday red tape. At the same time, web forums pour over each official word, each bulletin, each tweet from astronomy groups, hunting for hints, contradictions, traces of teamwork. The battle over facts isn't really pitting the convinced against the doubters. It's more a clash between folks who rely on official channels and those swayed by trends, between the crowd that assumes the dull option until facts say different, and the ones who suspect a veil until evidence clears it. Reality, whenever it emerges, will probably blend aspects from either side. Much of the hush likely stems from routine snags, like botched readings, subpar datasets, or administrative drag. Parts could be intentional, a brief standstill as unlikely bedfellows discuss ramifications and paths forward. Sorting the everyday from the calculated without peeking inside closed-door talks and choices is a tall order. We're stuck divining from scraps, decoding hints, crafting tales from what's missing. One undeniable fact, the shared reticence among usually rival organizations stands out. Be it planned alignment or sheer chance, purpose or fluke, we can't declare it definitively yet. Still, the issue lingers in the online ether, unresolved and growing pressing. Who chose to keep the globe in the dark about whatever crossed Mars's view? Part 10. The covert struggle over the storyline. Cyberspace isn't one unified realm. It's an arena of clashing worldviews, each side wielding captures, references, and unshakable conviction. On one side hunker the fact-checkers, the doubters, those who've watched countless online enigmas dissolve under close inspection and won't budge until bold assertions back up with solid proof. They eye the perseverance blur and spot camera artifact, sensor glitches, wishful thinking. They cite the void of supporting info from alternate sources as proof there's zilch to back up. They call on Occam's razor, the idea that straightforward answers trump elaborate ones, and claim that processing lags, fuzzy inputs, and our innate hunt for shapes add up to the spectacle unfolding right now. No plot needed, no extraterrestrials involved, merely humans projecting desires onto unclear visuals. Over in the rival camp are the spotters of the odd, those who scrutinize identical evidence and detect consistencies too precise for random chance, a hush too unified to dismiss as no coincidence. The composition seems too peculiar to occur by chance. Experts document these odd traits: an elevated carbon dioxide concentration relative to water, traces of nickel absent typical iron, a seemingly tubular form, coordinated disruptions across multiple organizations. Skeptics contend that any single irregularity could stem from ordinary causes, yet their combined occurrence surpasses what plausibly counts as coincidence. They probe thorny issues, such as why bodies that publicized monitoring intentions have withheld findings, or why amateur astronomers supply the sole accessible visuals instead of government outlets. This clash between factions unfolds not via arms, but through persuasive arguments, selective data analysis, and online platforms mechanics that boost indignation and conviction at the expense of subtlety and skepticism. Automated accounts, backed by governments or profit-driven entities, inflate targeted stories, lending undue prominence to marginal ideas. Content filters in places like China dictate which astronomy topics filter through to local viewers, molding the info landscape in manners opaque to external observers. The identical incident, filtered via varied digital channels, can seem utterly transformed. Selective facts, devoid of background, render shared agreement elusive. Still, this goes beyond malicious interference alone. Legitimate debates arise even among those scrutinizing evidence earnestly. Seasoned stargazers, versed in comet signatures over years, diverge on the import of chemical oddities. Specialists in visual enhancement debate if the persistent blur reveals authentic form or processing flaws. Hazard assessors arrive at starkly contrasting odds based on starting points and premises. The core of inquiry ought to settle such rifts via scrutiny, testing, and verification. Yet with vital sightings sequestered in restricted vaults, progress halts, leaving us to debate mere hints. For those sifting through this terrain, essential guidelines prove vital. Core tenet: irregularities demand replication. Should 3i/Oumuamua exhibit truly aberrant architecture, subsequent scans must validate it. If the makeup proves inherently strange, separate readings from varied tools ought to align. A lone reading, a fuzzy snapshot, a disputed figure, these fall short of appending comet lore or asserting engineered artifacts. Inquiry thrives on repeatability, uniformity, and evidence build-up. Next guideline: insist on openness. Agencies funded by taxpayers owe their insights to the public. When surveys are heralded yet never disclosed, when repositories meant for photos stay oddly barren, this signals a lapse in accountability, irrespective of the content itself. Everyday rationales warrant straightforward proof. If the quiet stems from standard workflow snags, officials must state it plainly. Offer schedules for unveiling info. Rebuild trust via dialogue, not mere hush. Another guideline: separate missing proof from proof of nothing. Unreleased photos don't confirm exotic sightings occurred, nor do they affirm none did. Uncertainty reigns, a blend of possibilities until fresh input resolves it. Rushing to firm beliefs, unwavering faith that 3i/Oumuamua is merely a wanderer, or unyielding assurance it's extraterrestrial craft, lacks sound reasoning. Final guideline: embrace the wonder, yet stay inquisitive. One can revel in the enigma absent pledging to one theory. One can push for superior evidence without hasty judgments. One can challenge official reticence without veering into distrustful plots. Inquiry excels in embracing disciplined ambiguity, at ease with gaps, driven to close them. The covert struggle over interpretations persists until facts surface or the tale dissolves amid web squabbles. Yet the fray itself pales against its insights into our ties to authorities, to proof, to mysteries. We dwell in an era of widespread raw probe feeds, yet scant expertise to parse them rightly. An era where code favors rifts and prizes fury. An era where the divide between specialist insight and lay grasp looms largest and most pivotal. 3i/Oumuamua, regardless of its true nature, now serves as a lens exposing our shared fears regarding oversight, candor, and if leaders disclose realities or shape our views. The entity itself, hurtling outward from the solar grasp. The unstoppable path of that interstellar intruder pays no mind to our heated discussions. It couldn't care less if we get its true nature right or overlook it completely. Yet we do care, because probing the mystery of the three-eyed Atlas boils down to questioning our own identity, our solitude in the cosmos, and the reliability of the systems we've erected to uncover truths. The battle over stories rages on. Fresh details will emerge through leaks or official disclosures. More breakdowns will surface in publications. The back and forth of assertions and rebuttals will keep spinning. Right now, though, Hovering in this limbo between revelation and understanding, one truth stands firm. Whatever lurks in those Mars surveillance records is undeniably there. The information holds up. Those photos, whether sharp or fuzzy, straightforward or puzzling, mundane or mind-blowing, reside on some distant servers. In time, via proper outlets or covert drops, they'll come to light. The real issue is if we'll be prepared for their revelations. Part 11. The Emerald Streaks, Atlas, Lemon, and Swan. As Mars falls into hush, the heavens erupt in clamor elsewhere. 3 comets, 3 radiant emerald intruders, all popping up in that tight time frame, have sparked joy in hobbyist stargazers and drawn in everyday folks to scan the night. C/2025 K1 Atlas, distinct from the debated cosmic drifter, gains luminosity in the early morning glow. C/2025 A6 Lemon charts its independent course, best spotted with field glasses or basic scopes. C/2025 R2 Swan completes the set, a fresh arrival pushing the tally to 3 concurrent emerald comets when usually we'd spot just one, if any. The web, that vast shared mind, buzzes over the serendipity, posts snapshots, wonders if this is routine or a sign of oddities overhead. Let's clear up the hue right away, since shades in the stars can deceive. That emerald shine stems from diatomic carbon, the C2 molecule, 2 carbon atoms linked, born in the comet's envelope as solar rays dismantle richer organic stuff. When the sun's UV rays energize these C2 units, they release light particles at precise green spectrum bands, near 510 and 515 nanometers. It's akin to the mechanism behind northern lights, just with altered elements. The outcome? An emerald veil around the core, most vivid at the heart where gases erupt strongest, tapering off at the fringes as the envelope thins into the void. Emerald comets aren't uncommon. Plenty glow green upon flaring up, once gas release ramps up to yield noticeable C2 output. The rarity lies in 3 shining vividly enough to catch eyes all at once, crafting a display that stirs pattern-seeking and sync spotting. Linked in some physical way? Absolutely not. From the same source? Nope. Their paths diverge entirely. Spotting stretched over months. Traits differ widely. They simply overlap in our cosmic backyard, each tracing its solo route, each peaking on its private timeline. But such alignment strikes as eerie when you're attuned to the weird. The three-eyed Atlas uproar has tuned folks to any sky anomaly. A standard celestial happening, 3 fairly luminous comets in close succession, turns shady through sheer proximity. Online forums gather reports, flag the overlaps, weave ties that might be illusions. 3 emerald comets together, and three-eyed Atlas clams up. What's the likelihood? Likelihood hinges on framing the puzzle, naturally. Comets obey no calendar. Their comings seem haphazard to us, shaped by gravitational dances forged eons ago. Even so, the call to gaze is genuine and worthwhile. These are approachable sights, no elite gear needed, catchable from clear sky spots by anyone with persistence and a celestial map. C/2025 K1 Atlas hits max glow in late October, appearing pre-dawn eastward. C/2025 A6 Lemon mirrors that rhythm, a touch fainter, calling for binoculars among typical viewers. C/2025 R2 Swan, the newest find, caps the Emerald Trio. Each serves as a nudge that our solar neighborhood isn't barren vacuum, but a lively arena of shifting bodies, collisions, and changes. For beginners, spotting tips are simple. Seek out spots far from urban glare, where artificial lights won't wash out dim targets. Consult star maps for up-to-date spots, as these wanderers shift against fixed stars each night. Give your vision a 20-minute dark adjustment, widening pupils and tuning eye cells for peak low-light pickup. Hunt for a hazy blob, unlike a star's crisp dot, maybe with a subtle tail stretching sunward opposite. Field glasses or a compact scope uncover finer points. The emerald tint emerges clearly where unaided sight picks up just a soft shimmer. Stellar magnitude in astronomy gauges brightness using a magnitude system that decreases as objects grow more luminous. The sun shines at magnitude -27, while the full moon registers at -13. The dimmest stars detectable by eyes adjusted to darkness hover near magnitude 6. Unlike pinpoint stars, comets spread their light over a broader expanse, making them seem fainter than their overall magnitude implies. A comet at magnitude 5 could show up as just a hazy smudge, scarcely noticeable, whereas a star of the same brightness would stand out clearly. Grasping this concept sets realistic hopes. These verdant comets won't dazzle as showstoppers blanketing the heavens with unaided sight. Instead, they're understated wonders, demanding patience and ideal settings. Prizes for enthusiasts who rise early and escape city lights. Capturing the thrill of spotting a comet defies easy words, yet it's profoundly felt once encountered. Intellectually, one grasps that this wanderer has journeyed from the solar system's fringes, maybe originating in the Oort cloud, billions of miles distant, tracing a path molded by gravity's tugs across eons. Visually, it captivates with its gentle radiance and, if present, a tail unfurling like an ethereal streak amid the constellations. Then comes the profound disorientation, the awareness of perched on a world circling a sun, observing yet another body locked in the same stellar dance. Each hurtles through the void at speeds beyond ordinary comprehension, though relative motion tricks us into sensing stillness. No evident ties bind these three comets to 3I Atlas. They're unrelated companions, neither vanguard nor fleet in some orchestrated descent. These are homegrown solar system relics, frozen remnants from our local expanse, not aliens from beyond. Their synchronized emergence is mere chance, though a compelling one that stokes tales around the broader enigma. Yet in a cosmos so immense and ancient, rare occurrences turn commonplace over endless trials. The odds of 3 fairly luminous comets surfacing at once are slim, yet feasible. Stripped to basics, it's ordinary. Set against lingering riddles of the interstellar intruder, it chills. What this cluster offers is perspective, underscoring comets' abundance, diversity, and dynamism. Far from scarce oddities, they're standard fixtures in stellar realms. Likely, every sun harbors its own comet reservoir, frozen scraps from birth, nudged by rogue stars and galactic currents into paths that sometimes loop sunward. Our domain is a barrage zone, a stellar arcade where impacts and near misses forge the young solar system and still deliver chances for study alongside threats to our world. These emerald comets level the playing field in astronomy, unlike Mars viewings. Professional gear is essential for glimpsing 3I Atlas. Spacecraft records are needed to confirm its cigar shape. But anyone can venture out pre-dawn, gaze skyward, and catch these trio with bare eyes or basic binoculars. It's raw, immediate, intimate. No filters, no gatekeepers. Institutions can't gate it. No blackout can obscure it. The night sky reveals freely, unlike guarded agency vaults. That openness clashes sharply with the official reticence on 3I Atlas. We're wired to behold reality firsthand, to rely on our senses. When filtered feeds and vague postponements supplant that, it stirs a void beyond simple inquisitiveness. So seek out the green comets, savor their sight, snap pics to share, guide kids in spotting them, and revel in the cosmos staging spectacles heedless of official disclosures or secrets. As you linger in the chilly pre-dawn hush, eyes fixed on distant jade gleams from billions of miles off, keep in mind that our world draws scrutiny too. Our globe isn't shielded from the oddities stirring across the wider solar domain. We're players in the grand celestial drama, aware or otherwise. Part 12. Earthquakes. Kamchatka's wrath. The surface refuses to settle. Not here in Kamchatka, where the Pacific Plate thrusts under the Eurasian one through subduction, forging one of Earth's premier volcanic hotbeds. Updates and broadcasts from Russia's remote eastern edge detail unusual tremors. Quakes grouping in ways that puzzle experts, defying complete analysis. Eruptive clouds soaring to heights that snarl flights and tint evenings in fiery oranges and violets. Kladachevskaya Sopka, Eurasia's tallest active peak at 4,750 meters, unleashes fierce blasts. Shivaluk, a key vent nearby, adds its share of ejecta and molten flows. The Ring of Fire, that curved chain of fault lines rimming the Pacific, honors its moniker with a ferocity that strikes witnesses as let's get straight to the facts we can verify versus the stories we spin in our heads. The Kamchatka Peninsula is perpetually restless. In subduction zones, one tectonic plate slides under another, producing non-stop seismic rumblings. This friction sparks quakes, while molten material pushes up through cracks to nourish volcanoes. The area experiences thousands of tremors annually. Many are minor and go unfelt, but others pack enough punch to harm structures and utilities. Eruptions happen frequently, ranging from gentle lava flows to violent blasts that pose real threats. This is just standard Earth science. The ceaseless way our planet sheds internal heat and recycles its crust, a dynamic that's molded the globe over billions of years. What stands out about the recent stir, assuming it's not just our tendency to spotlight everyday occurrences through biased lenses, is the apparent bunching up of incidents, their alignment with other oddities, and how monitoring tools like seismographs and online cameras turn into fodder for broader tales involving 3I loss and extraterrestrial guests. Online video platforms broadcast non-stop views from Kamchatka's volcanoes. Round-the-clock streams capturing radiant molten rock, plumes of ash, and the fierce force of subterranean energies piercing the surface. Viewer discussions overflow with guesses. Fluctuations in solar output, pulls from gravity elsewhere in the system, clouds of cosmic debris, shifts in magnetic fields, or even alien craft directly sparking quakes via impossible physics that feed our craving for drama. Might changes in solar winds tweak Earth's ionosphere and air layers in manners that sync with quake patterns? Truthfully, no proven link ties space weather to seismic shifts. Sunspots disrupt orbiting tech, electrical networks, signal relays, and polar lights. They squeeze the protective magnetic shield, warm high-altitude gases, and spark electrical flows up there. Yet these impacts play out miles above ground level, distant from the deep crustal stresses that cause shakes. The power scale doesn't match either. A big quake unleashes force akin to thousands of atom bombs. Solar streams, though packing huge overall energy over immense expanses, deposit tiny amounts per area on our planet. What about space dust trails tied to comets or far-off intruders, igniting eruptions? Once more, science offers no pathway for that. Vents blow when underground melt builds pressure beyond the rock's hold. As gases form and grow, or stresses open routes for hot flows to surface. These stem from the planet's inner furnace, unaffected by outer space happenings past the air envelope. Still, our brains seek links, particularly amid a flurry of strange happenings in a short span. 3 Atlas glides by Mars without fanfare. 3 green comets light up our night sky. Kamchatka unleashes what seems like fiercer outbursts. An asteroid brushes Earth closer than certain orbiters. Taken alone, each is ordinary or readily accounted for. Viewed together, they weave a tale that resonates deeply. A sequence begging for meaning, even if it's illusory. This is how clustered oddities play on the psyche, the spark behind every wild theory and real breakthrough alike. The trick lies in teasing apart real ties from mere overlaps, actual sequences from seeing faces in event clouds rather than pictures. Experts provide stats crunching, cause-effect frameworks, lab tests, but wielding them demands open data and clarity. If key happenings face secrecy curbs, if cosmic watchdogs hush on promised updates, if what's usual gets debated, sorting real signals from static gets tougher. Kamchatka's unrest ties into our larger yarn not through actual bonds to 3I Atlas, but by illustrating how disconnected happenings tangle into plots when folks are tuned to spot ties. It highlights how instant broadcasts and online networks reshape news spread, thrusting local shakes into worldwide spotlights immediately, drawing takes from crowds lacking Earth science know-how or local insights. It underscores the urge to amp things up, to raise the drama, to pull the plot from remote Martian orbits into our world's quakes and fragilities. Our ground shakes due to its innate tectonic vitality, because crustal drifts persist as the world cools from its 4.5 billion-year birth. Any sync with surrounding news is happenstance until evidence says different. Yet random chance chafes when you witness ash towers climbing skyward or scan alerts on relocations and halted air travel. Lights, as you browse YouTube remarks insisting that major events are unfolding and authorities are withholding key details. Maybe the takeaway is that residing on a geologically lively world within an ever-shifting stellar neighborhood involves embracing unpredictability, appreciating how rare occurrences can bunch up coincidentally, and avoiding the urge to link every oddity into a sweeping, all-encompassing plot. Or maybe it's that when organizations neglect straightforward updates, when opacity supplants openness, folks will devise their narratives, spot their connections, and link points that might or might not sketch a logical image. Reality, as ever, resides amid the pull between doubt and curiosity, between insisting on proof and admitting what we don't grasp. Section 13. The Online Discovery, M87 Stream. 55 million light-years distant, an extraordinarily fierce mechanism plays out at the heart of a massive elliptical galaxy known as Messier 87, where a supermassive black hole, 6 billion times our Sun's mass, consumes nearby matter while ejecting a beam of particles and radiation that spans thousands of light-years across the void between galaxies. This beam remains linear, unified, structured, driven by magnetic forces that coil and intensify within the swirling accretion disk near the black hole's event horizon. Thanks to the James Webb Space Telescope's infrared prowess and exceptional clarity, we've obtained the sharpest views to date of this stellar spectacle, unveiling luminous clumps along the beam. Shock zones where particles speed up, generating vivid glows that appear crafted, despite their purely natural origins. The visuals are mesmerizing, truly awe-inspiring beyond mere scientific intrigue, touching on beauty that's nearly transcendent. Witnessing a stream that outstretches vast stellar groupings. Grasping that this formation has endured for eons, realizing the power it wields could sustain countless advanced societies. This stirs a profound awe at the cosmos's potential for majesty. It's the natural world functioning on magnitudes and ferocities that render earthly worries utterly insignificant. Why link this to our tale of 3I/Atlas? It offers vital perspective on what artificial truly implies. The M87 beam appears constructed. It resembles a stellar hose, a focused power beam, a transit pathway, a colossal edifice. Its unwavering alignment, holding firm over thousands of light-years amid tugs from stars and dark matter, hints at precise adjustments and ongoing regulation. The shifting intensities along its path evoke mechanical elements with intent. Yet, through years of modeling and data validation, we recognize black hole beams as innate. They arise from established physics, angular momentum preservation, magnetic buildup via dynamo effects, particle boosting at shock boundaries, synchrotron glow from high-speed electrons curving in magnetic zones. The math is intricate. Models demand immense computing power, yet the display stems from core laws without needing agency or design. The natural realm, armed with ample fuel and apt setups, can forge patterns that match or exceed human ingenuity. This is the modesty science enforces, which conjecture often overlooks. Spotting order, symmetry, unity, seeming function. Our gut reaction calls for an architect, a builder, a mind at work. But space brims with rebuttals. Snow crystals with hexagonal patterns born from basic crystallization. Galactic spirals with graceful limbs molded by density ripples and varied spins. Saturn's rings graded by particle size via orbital harmonies. Intricacy blooms from the elementary. Harmony springs from disorder. Seeming artifice doesn't prove an artist. Turn this insight toward 3I/Atlas. Should Perseverance's shots reveal tube-like forms, odd compositions, or agency hush implying import, we should still entertain that the wilds are innovating in unfamiliar modes. The space beyond stars differs from our local setup. Bodies birthed near alien suns face unique radiation, chemical mixes, orbital pasts. We've examined just two prior interstellar travelers, 1I/Oumuamua, with its bizarre speed-up sparking arguments over comet status or otherwise, and 2I/Borisov, more typical in form yet varying in makeup from homegrown comets. Our dataset is minuscule. Our grasp of possibilities remains partial. The M87 beam further highlights how force and arrangement organization isn't the same as technology. The jet from a black hole delivers more power than the combined starlight across its entire host galaxy. It holds together overspans that light would need millennia to cross. It molds the space between galaxies, warming gases, curbing the birth of new stars, and guiding the growth of galaxy clusters. Still, it's devoid of intent or direction, merely the outcome of gravitational pull, magnetic fields, and thermodynamics. No more, no less. That said, we shouldn't ignore oddities or shy away from bold interpretations. Instead, we need to adjust our assumptions, understand that seeming engineered isn't proof of true engineering, and insist on several separate strands of proof before embracing ideas that upend established knowledge. The M87 jet appeared man-made until we grasped its origins. Those initial pulses in 1967 seemed contrived too. Steady radio signals so exact that scientists momentarily pondered alien signals, only to discover they were watching spinning neutron stars. Fast radio bursts struck us as fabricated until models emerged linking them to magnetars and supernova leftovers. The trend is evident. Nature's repertoire outstrips our creativity. Each wave of astronomers faces features that push the limits of what's anticipated, sparking thoughts of intellect or tech, which eventually bow to everyday causes as data piles up and theories advance. This isn't to say 3 Atlas has to be natural. It's a call to avoid leaping to artificial origins simply because an explanation eludes us right away. The deeper lesson here matters. Our cosmos can forge black holes that devour stars and hurl streams across galactic expanses. It operates under quantum rules for tiny particles and bends spacetime via general relativity near hefty bodies. It generates intricate patterns at all levels, from the infinitesimal to the vast, driven solely by physical principles without any directing force. To call on design too soon or assert artificiality without probing all natural options is to undervalue the ingenuity of those principles. But openness remains essential. If clues truly suggest artificiality, if everyday accounts keep falling short, and the crafted idea yields verifiable forecasts that hold true, we must pursue the evidence no matter the path. Science isn't for safeguarding cozy views. It's for refining our frameworks when facts require it. The M87 jet urges restraint, yet it shouldn't foster rigidity. For the moment, while we await Mars data that might resolve debates on 3 Atlas, the jet serves as a nudge that the universe brims with marvels we scarcely comprehend. Features that test our instincts and broaden our grasp of possibilities. Whether 3 Atlas adds to the roster of natural marvels or signals something truly novel, the universe stays more bizarre and awe-inspiring than we typically let on. Part 14. Enceladus, the life hidden under the ice. As Mars holds back on its cosmic guest, Saturn's satellite Enceladus hints at something perhaps even deeper. The ingredients for life, vibrant and reachable, bursting out via fissures in an icy crust over a worldwide sea. Recent studies released this week in Nature Astronomy examine newly expelled ice particles gathered by probe sensors on past close passes, processed and interpreted only recently. These particles hold intricate organic compounds. Beyond basic carbon setups, they feature bigger assemblies with nitrogen, oxygen, and chains of carbon linked in patterns hinting at advanced chemistry. Such elements form the foundations of amino acids, the forerunners to proteins, the vital components that underpin life as we recognize it. Let's keep this straightforward. Enceladus is minuscule, just over 500 kilometers across, compact enough to nestle within Texas boundaries with space left over. Its exterior is solid water ice, shiny and luminous, holding temps at -200 degrees. Yet under that shell, warmed by tidal stresses from Saturn's pull kneading the moon's core, stretches a sea of fluid water. We confirm this sea's presence through its outbursts via cracks near the South Pole. Fountains of steam and ice shards blasting hundreds of kilometers upward, with some breaking free to contribute to one of Saturn's faint rings. The Cassini probe, circling Saturn from 2004 to its intentional end in 2017, passed through these sprays repeatedly, employing mass spectrometers to probe the makeup of the spewed substances. The findings revealed water, naturally, plus salts, silica particles, hydrogen, and organics. Every find bolstered the argument that Enceladus harbors conditions ripe for biology. Enceladus harbors a potentially livable setting, an area where moisture, power sources, and chemical reactions interact in manners that might sustain organisms. Recent examinations emphasize the intricate organic compounds, substances that are too elaborate and organized to qualify as mere impurities or accidental byproducts of cosmic rays. Spectral patterns align with materials detected in certain space rocks, the carbonaceous chondrites that transport organic elements from the solar system's formative era. Yet the organics on Enceladus appear new, either freshly generated or newly uncovered. They aren't outdated remnants, but ongoing chemical processes unfolding at present. This suggests the hidden sea under the frozen shell isn't merely H2O in liquid form, but a bustling reaction chamber, possibly featuring underwater hot springs on the ocean bottom, where heated, mineral-laden fluids encounter chilly seawater, generating chemical disparities that biology might harness. This doesn't confirm the presence of life. No metabolic activity has been detected. No cellular structures have been spotted. No genetic material or comparable data-storing substance has been pinpointed. Instead, we possess signs of an environment's suitability for habitation, a realm where existence could thrive if it originated or arrived there. Here on our planet, liquid water paired with energy availability and molecular variety always yields life forms. Submarine vents, frozen over lakes in Antarctica, corrosive thermal pools, salt-saturated basins, and even subterranean stones kilometers deep all teem with bacterial ecosystems. Organisms prove resilient, versatile, and adept at thriving in spots that defy our expectations rooted in surface conditions. Might Enceladus sustain life? Absolutely, it's possible. The chemical makeup looks encouraging. The power supply, driven by gravitational flexing instead of solar illumination, proves adequate. The timelines align well. That subterranean ocean likely persisted for eons, providing ample duration for life to develop if circumstances allow. If organisms truly inhabit it, though, stays a mystery, one that demands first-hand collection, expeditions to pierce the ice crust or scrutinize ejected particles using gear far beyond what Cassini possessed. The twist in this tale is both intriguing and aggravating. Aerospace organizations freely address biology-conducive reactions around Saturn, release studies in top-tier publications, and stage media events to hail the unearthing of sophisticated organics. The signal is unmistakable. Enceladus merits pursuit, investigation, and could represent a cradle for life's duplicate genesis, appending fields like biology and metaphysics. In contrast, those entities hush up photos from Mars captured during the 3 Atlas pass. They ignore data they once highlighted, fostering doubt and conjecture through their reticence. What accounts for this uneven openness? Maybe because Enceladus, for all its scientific allure, doesn't trigger urgent threats to our worldview. Unearthing tiny life in its waters would mark a monumental, resume-boosting, news-dominating breakthrough. It would reveal that existence emerges wherever feasible, that biology might saturate the cosmos, that solitude isn't our fate. Yet it would remain a subject for study, a form of life that doesn't undermine our engineering dominance, a phenomenon operating on scales and distances that intrigue without endangering. An extraterrestrial artifact exhibiting engineered traits would alter everything. It wouldn't stem from our methodical searches. It would signify machinery that encountered us, traversed our stellar neighborhood, and showcased feats beyond our grasp. The fallout would ripple past research into politics, security, faith, all spheres shaping human identity. Such a find wouldn't solely credit experts. It would impact all, prepared or otherwise, sans opportunity for deliberation or agreement. Thus, space bodies chat about Enceladus while muting 3-2 Atlas, not due to unequal value, but because the former slots neatly into current paradigms, whereas the latter risks shattering them completely. This conjecture, while unproven, aligns more closely with known details than competing theories in circulation. The Enceladus updates also underscore that our solar neighborhood isn't inert, a mere assortment of frigid asteroids circling a sun. It's vibrant, chemically vibrant, brimming with habitats we scarcely comprehend. Europa, yet another satellite boasting a buried ocean, offers comparable potential. Titan, Saturn's biggest satellite, features ponds of methane liquid and organic reactions so elaborate that experts dub it an innate lab for chemistry preceding life. Mars too might conceal viable zones in profound groundwater or frozen reserves, refuges where germs could endure amid the unforgiving terrain. Our cosmic domain brims with prospects, and we've scarcely scratched its surface. That organizations can divulge some findings candidly, while veiling others hints at a behind-scenes calculation we lack access to, a triage of knowledge into bins of safe for public and needing further handling. It's crucial to think deeper about this dynamic, deciphering the unspoken rules that decide which breakthroughs earn headlines and which fade into obscurity matters just as much as grasping the breakthroughs themselves. For the moment, take a moment to applaud the revelations from Enceladus. They exemplify science at its finest: meticulous examination, scrutiny by experts, transparent sharing of results, and straightforward explanations of certainties alongside lingering doubts. Use this as a benchmark to evaluate the three-eyed Atlas case. Insist on identical openness, the same level of scrutiny, and an equal dedication to making information accessible to everyone. Keep in mind, too, that if life could arise in the subsurface sea of a diminutive icy satellite, warmed by gravitational pulls, if chemical reactions could evolve into living systems in settings we once dismissed as unlivable just decades back, then the cosmos is infinitely more bizarre and alive than we usually permit ourselves to imagine. Part 15. The 250-mile enigma. On a typical Tuesday afternoon, the vast majority of people on our planet carried on with their routines, oblivious to the fact that a cosmic boulder about the size of a modest home grazed by Earth at roughly 250 miles, or 400 kilometers, up, right in the orbital zone of the International Space Station and numerous satellites. Dubbed Asteroid 2025 TF in the precise, administrative style common to celestial naming conventions, it was only identified mere hours after its nearest pass, picked up by monitoring scopes built to spot precisely such intruders, though not always with enough lead time for alerts. The figures are stark. In the grand scale of space, 400 kilometers amounts to little. It's scarcely worth noting. That's the height at which space shuttles use to soar and where certain private satellites carry out operations. This wasn't some remote pass observed from afar across millions of miles. No, this was a narrow escape, an entity that might have plunged into our air layer with a minor shift in path, unleashing destructive power akin to several nuclear blasts had it hit inhabited zones. The real jolt isn't that it sailed by without harm. The jolt lies in how we nearly overlooked it entirely. Scale plays a key role. Asteroid 2025 TF is modest, likely spanning 10 to 20 meters based on its makeup and albedo. Items of this dimension are tough to detect, particularly when they come from angles that silhouette them against the bright sky or close to the sun, out of reach for earthbound observers. Our tracking networks are advancing. Inventories are expanding. Spotting success is on the rise. Yet vulnerabilities persist, shadowed areas allowing these visitors to evade notice until they've zipped by, or perilously, until they've begun descending into our atmosphere. Reflect on the Chelyabinsk meteor of 2013, a 20-meter chunk that detonated above Russia, releasing force comparable to 400 kilotons of TNT, smashing panes throughout a metropolis, harming more than 1,000 individuals, and captivating the globe with car-dash videos of an inferno outshining daylight. It caught us off guard. No alerts preceded it. For most, the initial sign was the dazzling burst followed by the rumbling pressure wave that arrived shortly after. Asteroid 2025 TF had the potential to mirror Chelyabinsk, a sudden jolt, a wake-up call that residing on a world amid a stellar neighborhood involves coexisting with scattered rubble. Some benign, others capable of vast ruin. The factors behind missing such threats are basic: compact dimensions, blistering velocity, tricky positioning. Spotting demands bouncing sunlight our way, rendering sun-facing arrivals virtually undetectable until they've swung around to backlight against the night. The phase angle, the span from sun through the body to the watcher, profoundly influences visibility. An asteroid might appear thousands of times dimmer on approach than departure, solely from lighting setup. Velocity intensifies the challenge. These travelers zip along at kilometers per second, streaking across a scope sight in mere moments or instants, necessitating smart algorithms to separate wanderers from fixed stars and clutter. Initiatives like the Catalina Sky Survey and the forthcoming Vera C. Rubin Observatory tackle this head-on, methodically sweeping the heavens, compiling lists of tracked asteroids, and plotting paths to forecast upcoming brushes. Advancements are tangible. The count of documented near-Earth asteroids has surged from mere hundreds in the 1990s to tens of thousands now. Still, full coverage slips away. We've likely tallied most kilometer-scale behemoths, the global threats. We've located plenty of 100-meter ones, city wreckers. But the 10 to 50-meter class, neighborhood razors, or area-wide calamities, stays frustratingly undermapped. Asteroid 2025 TF slots neatly into that dreaded profile. Big enough for serious havoc, tiny enough to dodge our nets until it's perilously near. If something can glide within 400 kilometers undetected, if something like an asteroid can approach nearer than numerous satellites without warning, what other phenomena might escape our notice? This isn't a mere figure of speech. It's a pressing reality tied to safeguarding our planet, demanding funding, collaboration, and global partnerships. Link this revelation to the enigma of 3 Atlas and the broader storyline. Suppose we overlook a rock hurtling inside the paths of our probes. Consider then how much we might misjudge an extraterrestrial interloper glimpsed fleetingly from our world before it vanished amid Mars's glow and solar brilliance. When monitoring lapses permit items to evade detection, how assured can we feel in our grasp of 3 Atlas, drawn from sparse sightings and debated evidence? The challenge of oversight extends far beyond mere space rocks. It encompasses all entities traversing our stellar vicinity, whether organic or artificial. The systems monitoring orbital debris outperform civilian setups, boasting greater precision and breadth. The U.S. Space Force, evolving from the Air Force Space Command, keeps tabs on countless items circling Earth and farther out. Nations like Russia, China, and fellow space powers possess comparable tools. Such arrays excel at following diminutive targets like asteroid 2025 TF, provided they adhere to steady Earth-centric trajectories. Yet, cosmic wanderers from erratic angles, hurtling at tremendous speeds, pose tougher challenges. They defy the routine circuits of terrestrial orbiters. They emerge suddenly, sweep by, then fade away, frequently before thorough analysis. This backdrop illuminates the puzzle of 3 Atlas. We're operating with partial vision. Our instruments pack a punch, yet fall short. Our detection span advances steadily, but harbors voids. Assessing rapid transients hinges on diverse viewpoints yielding repeated captures, the precise intel a Mars encounter ought to yield, yet absent from open archives. Should asteroid 2025 TF infiltrate our barriers at a mere 400 kilometers, what secrets could 3 Atlas conceal right under our noses, merely for want of clearer records? The overarching lesson surpasses any single anomaly. Detection shortfalls combined with delayed disclosures breed ripe soil for speculation, anxiety, and falsehoods. As organizations withhold prompt updates, as surprises jolt us, as post-event revelations emerge, credibility crumbles. Folks start questioning hidden truths. What further brushes or collisions went unreported, whether watchdogs over cosmic perils prove reliable and open, or if they're swamped in covert. Asteroid 2025 TF will soon slip from news cycles, reduced to a mere entry in near-Earth inventories, a metric in collision probability forecasts. Yet it ought to jolt us awake, underscoring our existence amid a cosmic barrage, that the void teems with activity, that our informational voids loom larger than the average mind grasps. And where such voids overlap with riddles like 3 Atlas, where tracking mishaps amplify messaging breakdowns, we witness precisely today's scenario: a populace craving clarity, bodies hesitant to deliver, and a tale scripting itself in the void between inquiry and reply. Bridging the narrator's hush. Step back. Expand the view. Grasp the full mosaic piece from shards, pauses, and lingering queries. Your display assembles the collage, the tubular blur from perseverance, stretched and enigmatic, shimmering versus the Martian backdrop. 3 verdant streaks dotting Earth's early morning shadows, distinct yet bound by schedule and hue. The M87 stream lurking afar, a stellar geyser spanning a galaxy 55 million light-years distant, illustrating how the cosmos crafts wonders eclipsing our wildest thoughts. Enceladus, petite and icy, concealing a sea that could nurture existence. Kamchatka belching russet and ash, showcasing our world's raw temper. And nestled in restricted vaults, the reality of three atlases form as beheld by various probes near Mars. Each gleam overhead weaves a tale. Those comets narrate epics of frost, soot, and ancient epics of relics forged eons past, now nudged towards solar embrace. The boulder grazing Earth at orbital heights recounts brushes with disaster and observational flaws of a universe heedless to our frailty. Enceladus whispers of veiled waters and intricate reactions of prospects we're just starting to probe. The M87 stream recounts power, pull, and the cosmos's flair for Splendor Sand's design. And 3 Atlas, its chronicle hangs incomplete, poised amid sighting and unveiling, betwixt gathered intel and unveiled shares. The chroniclers, the space outfits with their gear and stores, have opted for quietude. Whether this quietude signals mere prudence, collaborative efforts, administrative sluggishness, or a more intentional strategy remains unclear for now. Yet the void left by their reticence has allowed alternative perspectives, competing accounts, and diverse analyses to gain traction. The real puzzle overshadowing it all isn't the essence of 3 Atlas itself. Rather, it's about who holds the reins on revealing the truth, and why those gatekeepers deem withholding information preferable to candor. Scientific progress depends on transparency, the unfettered sharing of findings, and the capacity for outside experts to scrutinize, refute, or build upon one another's efforts. When that transparency falters, when sightings are publicized but raw data stays hidden, when rival organizations that typically vie for recognition abruptly unite in their reticence to disclose, we confront the disquieting truth that the engines of innovation can double as instruments of restraint. It's possible the Mars photographs capture precisely what we'd anticipate: a comet, hazy and ordinary, noteworthy from a research standpoint, but hardly revolutionary. It's possible this hush stems from nothing grander than the cumbersome gears of vast organizations, the everyday truth that verifying and disseminating data demands patience. It's possible that in half a year or a full year, repositories will overflow with visuals, publications will emerge, and we'll regard this interval as a lesson in hasty conjecture, a warning against overinterpreting standard holdups. Or maybe events are unfolding in closed rooms we can't access, discussions we can't eavesdrop on, involving individuals privy to details beyond our reach. Maybe the visuals reveal formations that defy easy classification. Maybe the composition proves odder than initial accounts implied. Maybe military detectors captured anomalies that public tools couldn't conclusively identify. Maybe a subtle, unified choice was reached to manage this finding with deliberation, synchronization, and groundwork prior to any unveiling. The truth is, we lack certainty. That's the forthright response, the methodically sound stance, the declaration that accommodates both scenarios without rushing to embrace one. We lack certainty simply because those in possession of it haven't shared. And as the delay stretches on, the quiet grows more resonant, the rival theories more intricate, and the challenge of rebuilding confidence intensifies, even should the ultimate disclosure prove utterly routine. One thing we can affirm without doubt: 3 Atlas traversed Mars on October 3, 2025. Numerous probes detected it or strove to do so. Information was gathered, relayed, archived. Experts pored over that material. Summaries were drafted. Judgments were formed. All these steps occurred. The knowledge persists. It resides in digital storage, repositories, secure or exclusive vaults, pending dissemination, unauthorized disclosure, or the gradual erosion of restrictions through time. The entity in question, unconcerned by our arguments and urgent quests for clarity, pursues its eccentric trajectory away from the Sun. It will venture past Neptune's path, past the Kuiper belt, returning to the voids between stars, with no recurrence. Subsequent sightings will grow ever more arduous as it dissolves into the cosmic gloom. Should we have forfeited our window to comprehend it? If the Mars encounter offered a singular prospect now wasted through reticence or concealment, we might forfeit it forever. The opportunity narrows, the instant slips away, and the bodies in charge remain mute. Each gleam overhead narrates a tale, yet certain tales get voiced while others stay locked away. That divide discloses more about the narrators than the heavens above. We're compelled to ponder, to hypothesize, to press for resolutions that could arrive or evade us entirely. We're left observing the hush, deciphering its nuances, questioning why those empowered to enlighten opt for obscurity.